All right, so let's tackle exercise 6. We have an article reporting that 69% of the general population belong to a religious community. So we got a P here. In a survey on internet use, 378 out of 512 religion surfers belong to a religious community. So it looks like we have an X, number of successes, out of a sample, an N, and this must be the P that we're testing. And so just to pay a little bit close attention here, this P is about the general population, and this sample is from what we would call religion surfers. So we're trying to see if these two things are similar. That's what we're going to be comparing. Additionally, I like to point out that the actual variable here is belonging to a religious community, which is a yes, no. So we are dealing with a categorical binary variable. So the last sentence then says, is there convincing evidence that the proportion, in case we weren't paying attention to all those other keywords, of religion surfers who belong to a religious community is different from the general population? So no direction here. We don't think it's more. We don't think it's less. We just think it's different. So if we're going to set up our hypotheses, it's either the same as the general population based on that article, or it is not the same. Right? So the only P that we have running around to even throw into our hypotheses is that 69%. And then we have that keyword of different telling us we don't care about our direction. Calculating the test statistic and calculating your corresponding p-value. For those of you with the sweet graphing calculator, this is all in one prop Z test. So if you have the graphing calculator, you should start that now. If you don't have the graphing calculator, I'll walk through the steps. The rest of you can just fast forward. So calculating your test statistic, as always, this is on our formula sheet. We are doing a hypothesis test. We had that keyword of proportion, right? We're doing a test. So we're going to use that formula. We're just going to copy that down onto our page. Z is equal to P hat minus our P naught all over the square root P naught Q naught over N. So we need to figure out our P hat, right? That takes a little bit of work. 378 divided by 512. Let me bust out my calculator. 378 divided by 512. Looks like we have 73.83. And remember, when you want to keep your 4 decimals, otherwise you're going to end up with a z-score that's significantly different than what it should be. So 0.7383 minus 69. So basically, the problem that we're solving here is we're saying, well, if that religion surfers have the same proportion as the general population, if it is 69%, what are the chances that we get 73% out or something more extreme? And since this, we don't care which direction, it could have been more, it could have been less. So this is what we're looking for as a two-tailed p-value. And this is all divided by the square root 0.69, because this is about the same as our p naught, right? 0.31, that's just 1 minus that, all over the 512. So I'm going to go ahead and do this in the calculator now, because I don't want to type all that in because I'm lazy. But if you don't have the sweet calculator, you should be typing that into your calculator, making sure you get the same value. We're testing 69%. We had 378 out of our 512, and we have a not equal to for our alternative. So we get out a z-score of 2.36. Z-scores are the only thing I'm okay with rounding to 2 decimal places because that's the best you can do in the table. By the way, just to point out for those of you with the graphing calculator, when I went over to one prop Z test, there were 2 options at the end, calculate or draw. If you choose draw, it'll draw that little picture I just drew, boop, boop, and it will give you the z-score and the p-value there. So you can always do that, and it gives you both the z-score and the p-value instead of giving it all in the list, and then you got a drawing as well. So from the calculator, our p-value was 0.0182. For the table, folks, we got to go look up. Instead of looking at positive 2.36, I'm going to look up negative and just get this side. So table, past our t table, negative 2.36, looks like we get 0.0091. And then we have to remember, since I had a not equal to, I need to multiply that by 2 because I want both of these tails. So 0.0182, same value from the table that we got from the calculator. All right, so the last step here is making our decision. And this question basically just gives us a bunch of different alpha levels to check or significant levels to check. We know our p-value is 0.0182. And we can compare it to all these different values that they give us. And so it is greater than 0.1, less than 0.05, 0.01, less than 0.02, and less than 0.1. So for this one, we would fail to reject. And for all these, we would reject the null. So opposite, opposite, and there's the only one that's correct. All right, so exercise 7 is one we're going to do in class, and I'll make videos starting after that.